Our definition of a function is a relation in which each input, each x, has exactly one output, one y. To state this a little differently, a relation is not a function if any input x corresponds to more than one output, where our output is y. So if a given input x has two different y values, it's not a function. We're going to go ahead and look at some different relations and determine if they are a function or not. First example is a table, input of 2, output of 3, input of 4, output of 7, so far so good. Then we get to input of 2, output of 1. So the same input x has two different outputs. 2 has an output of 3, 2 has an output of 1. This is not a function. One input, two different outputs, two different y values. The next example is a pretty straightforward yes. No x value is repeated, so we don't even need to look twice. 2 goes to 3, 3 goes to 7, 4 goes to 5. It's okay that there are two different 3's in the table. Each input x has exactly one output y. Let's look at some ordered pairs. So this is every algebra teacher's favorite trick question. The input of -1 shows up twice. That would lead you to think this is a no, but let's see what the output is. Input of -1, output of 1. Input of -1, output of 1. So even though the input shows up more than once, it always is going to the same output. So an x value of -1 always is paired with a y value of 1. This is a yes, this is a function. Next example must be a no, and it is. So we have the input of 4 going to an output of 5, x equals 4, y equals 5. But then we have a repeated input, which goes to a different output. So we have an input of 4 again, this time going to an output of 10. This is not a function. So when one x value goes to two different y values, that is not a function. This example right here of mappings, this is the one that really helps you see, do you understand what a function is? We have 3 arrows going to the same output. We have one input going to 3 different outputs. So the same input for 3 different outputs. Which of these is a function? Think about it for a second. Which one is a function? The first one is a function. Yes, it's okay that 5 goes to 9 and 6 goes to 9 and 7 goes to 9. Each input has exactly one predictable output. 5 always goes to 9, 6 always goes to 9, 7 always goes to 9. This is the no, not a function. This is the picture to stick in your brain of not a function. One input, 9, has 3 different outputs. It's not predictable. Given an input of 9, output of 5, output of 6, output of 7. Not a function. Last 2 examples are graphs. What we're going to do to determine if a graph is a function or not is we're going to go from left to right, and we're going to see if any input, any x, has 2 different outputs. So this input of -4, is that a -4? -1, 2, 3, of -3 has only one possible output. This output of -1, only one possible output. Input of 0, one possible output. Ooh, here's the problem. I need to change colors. When x is 1, y can be 1, or y can be -1, 2, 3, 4. So the same x value has 2 different y values. This is not a function. That's because I have an ordered pair 1, 1, and an ordered pair 1, -4. Same input, 2 different outputs. The rest of the points are okay. Last example is a yes. As I move across my grid, this x value has 1 y, this x value has 1 y, 1 y, 1 y, and 1 y. So each x is paired with only one possible y value. Again, are two ways to think about is it a function? You can use the definition. Each input, each x, has exactly one y. Or we can look to see that it's not a function. We identify a relation as not a function if we can find a particular x value with two different y values. That would not be a function.